editing, video. Hey guys, this is a bad math video on how to solve distance, rate, time, DRT problems. This is a bad math video. This is not a science video, so I don't want to hear any science stuff. It's a formula. We're doing math. Okay. So distance equals rate times time. If I'm driving 20 miles an hour for 4 hours, 20 miles an hour is my rate, 4 hours is my time, 20 times 4, 80 miles is my distance. If I drove 20 miles an hour for 4 hours, I would have gone 80 miles. Common sense, hopefully, kind of. So distance equals rate times time. So we're doing distance, rate, time, word problems. To do these problems, we're going to make a table. Table time. Then we're going to draw a little picture. And then we're going to solve. If you want to skip the picture drawing, it's no fun. But I guess it's okay. But it might cost you in the end because pictures are important. So let's do an example. Here we go. Two cars, 635 miles apart, start at the same time and travel toward each other. One car travels at 75 miles per hour. The other car travels at 52 miles per hour. In how many hours will the cars meet? All right, so step one, we're going to make a table. We got car A, car B. We got their rate, we got their time, and we got their distance, which equals rate times time. Okay. Car A, we'll say that was the one going 75 miles an hour, so its rate was 75 miles. Car B's rate was 52 miles per hour. Time, they both start at the same time, so their time is the same. So we'll call them both T for time. So distance equals rate times time. So car A went 75 T and car B went 52 T. That's their distance. Now we're going to actually solve for T. So step two, what are we doing? Drawing a picture. Car A, car B, or maybe the other way. So they're some distance apart and they're driving toward each other. Okay. Car A, I know how far he went. He went 75 T. Yeah. And car B, I know how far he went. He went 52 T. That total distance, how far car A went plus how far car B went, that should equal 635. If I look back at my problem, they were 635 miles apart. So I know altogether it should be 635. And this will help me set up an equation. So I know 75 T, how far car A went, plus 52 T, how far car B went, should equal 635. So I combine like terms. I get 127 T should equal 635. 635. Nice. Divide both sides by 127. So T equals 5. 5. So T is 5. So they were both traveling for 5 hours. And what's the question? In how many hours will the cars meet? They will meet in 5 hours because T was 5, and that's how long they were both traveling. So we set up a table, fill in the information, draw a picture, and the picture and the problem will help us find an equation to help us solve this thing. Yeah. I don't know. That works. On the bottom there, we got practice of just setting up a table. So first we're going to practice just with the table. And then on the back, you can try solving problems. So table problems, bottom, go, read, do, yes. On B, or no, practice one. It says two hikers start toward each other at the same time from different towns, and they meet in 6 hours. The rate of one hiker is twice the rate of the other. So I got hiker A, hiker B, rate, time, distance. This one, I know their times. What was it, 6 hours? They meet in 6 hours, so they're both, and they leave at the same time. They leave at the same time, so they've both been traveling. Their T, or their time, is 6. This one, I don't know their rate, but I kind of know their rate. I know how they relate to each other. It says that the rate of one hiker is twice the rate of the other. So if hiker A was traveling at X miles per hour, hiker B was traveling at 2X miles per hour. So to complete the table, I want the distance. So one hiker was his distance was 6x, and the other hiker was 2x times 6, 12x. And that is my table. It's beautiful. All right. Practice 2, Joanne and Susan driving opposite directions. Joanne left 3 hours later than Susan. So our table, Joanne, Susan, rate, time, distance. We know both their rates. Joanne, 50 miles an hour, and Susan, 45 miles an hour. It's the time that's tricky. So we know Joanne left 3 hours later than Susan. So we got a couple ways to think about it. If Susan left at X, then that means Joanne would have left at X minus 3. She left 3 hours later, so she's done 3 hours less traveling. So like if Susan was driving for 5 hours, then Joanne would have only been driving for 2 because she left 3 hours later. We could have also thought about it as Joanne as X and Susan as X plus 3. Because if Joanne has been driving for 1 hour, then Susan would have been driving for 1 plus 3, 4 hours, 3 hours later. So either way you want to think about it, I'll leave both tables up. So distance, so 50 times x minus 3 for Joanne, so she went 50x minus 150. And Susan would have been 45x. And then the other table would have looked like that if you did it that way. So either table could be used to solve a problem. Okay. We good? We good. On the back, we got actual problems where they give us enough information to make our table and then actually solve a problem. So we'll have to draw a picture and think. So do the back and we'll check it afterwards. Here we go, practice problems. Marcia, brother Don, left home, same time, traveling opposite directions. Don's rate was 6 miles per hour less than Marcia's rate after 10 hours, 940 miles apart. He's going to set up a table with both of their names and the rate and time and distance. All right, their rates. Don's rate was 6 miles less than Marcia's rate. So if Marcia was going X, Don was going X minus 6. 6 miles per hour less. He was going slower than Marcia. So, okay. After 10 hours, they both left home at the same time, so they both traveled for 10 hours. Their distance, Marcia was 10x, and Don was 10 times x minus 6, which is 10x minus 60. Don't forget to distribute. Yeah, we're good. Just drawing a terrible picture. There's the house they both left from. One went one direction. The other went the other direction. They went in opposite directions. Little car. Another little car. Yeah. Okay. So one of those is Don. One is Marcia. Marcia? Is this Marcia? Is that Marcia? Which one's Marcia? There's Marcia. There's Don. So we know how far Marcia went. She went 10x. That's the distance we found in the table. And we know Don went 10x minus 60. We know how far he went. It says after 10 hours, they were 940 miles apart. So from Don to Marcia should be 940 miles. So this helps us set up an equation. If I take Don's distance and add it to Marcia's distance, it should make the whole distance. So 10x minus 60 plus 10x should be 940, if this works, and it should. So 20x minus 60 should be 940 after I combine like terms. Then we got a two-step equation to solve. It takes a while. Blah, blah, blah. Add 60, add 60. So 20x equals 1,000. 20x, not 2x. He'll figure it out. They're not going 500 miles an hour. What went wrong? There it is, 20. 1,000 divided by 20 is 50. 50 miles an hour sounds better. So x is 50. Then we got to read the problem. It says find the rate of travel for each person. So Marcia was going 50 miles an hour because she is equal to x miles per hour. Label, word problems. Don was going 50 minus 6 miles per hour, so he was only going 44 miles per hour. Yeah, that's how you do it. Make a table, draw a picture. From the picture, create an equation. We're golden. Freight train leaves the station at 30 miles an hour. 2 hours later, an express train leaves the same station, traveling in the same direction at a rate of 50 miles per hour. And how many hours will the express train overtake the freight train? All right, so we got a freight and an express. Express seems to go faster than a freight. It tells us their mile per hourage. Freight was going 30 and express was going 50. So that's their rates. Time, what do we know about the time? It says 2 hours later, an express train leaves. So if a freight has been traveling for X hours, the express train has only been traveling for X minus 2 hours. It left 2 hours later, so it's been traveling 2 hours less. Sorry. Distance, multiply. D equals R times T, DRT. 30x and 50 times x minus 2 is 50x minus 100. Distribute. Picture time. So an freight train, which looks like a little chugga choo-choo with terrible express train, which looks... Maybe I'll superimpose better pictures. Anyways, freight train was traveling, and we know how far it went. It went 30x. And it wants to know in how many hours will the express train overtake the freight train. So they're both leaving at the same place, and how long will the freight train take to, or express train take to catch up? So if one went 30x and we know the express train went 50x minus 100, we want them both be the same. So they both traveled the same distance. So 30x should equal 50x minus 100 because we want when they're both equal when one train overtakes the other. So we got an equation with variables on both sides. Get all their variables on one side. So negative 20x should equal negative 100. Numbers on the other. Divide both sides by negative 20. And x equals 5. Negative 100 divided by negative 20 is positive 5. So x is 5. And here's the part, that problem. I'm going to pause it right here. Is he doing it? He's going to do it. Okay. So the question is, in how many hours will the express train overtake the freight train? Semantics. So I read that as how long will it take the express train to overtake the freight train? So I read that as it is asking me for how long has the express train been traveling. So I got to look at the express train's time. So it only took the express train 3 hours. 5 minus 2, 3 hours to do this. You could read it, I guess, in how many hours, like the freight train had been traveling for 5 hours, so it took 5 hours for the freight train to get overtaken. So I don't know. On a worksheet, if you had 5 or 3, I'd probably let it slide. I think 3 is better. 3 is the way to go. That makes sense, right? What are you going to say? All right. That is it, I guess. Make a table. Make a table, make a picture, make an equation, solve an equation. That's it. Distance equals rate times time. DRT. We got this. You got it. Yeah.